Welcome to another video on my Raspberry Pi 1 running Raspbian Linux, and for this project programmed in Python with stacked upon it RaspberryPi Plus with serial cable towards Minicom serial terminal, also network cable right here for VLC, and a newly constructed stand for my Raspberry Pi camera, raspicam for short, which is sending live video stream, although with a few seconds delay. And of course a band cable which is connected to this breadboard with some electronics, and in this case it is about this chip, a Max 5:2 digital to analog converter, which is controlled by SPI 3-wire. SPI I have also used for this chip, which is a digital to analog converter. Also SPI serial peripheral interface. The only difference is this is reading stuff to be read by the Raspberry Pi, which is also bidirectional. This one is only receiving because it's digital to analog, and 3-wire is an SPI version that is only half duplex. Full duplex, half duplex, which also means that the two wires that are here for one way and the other way are combined. Does it work yet? No, not yet. I have found a few problems also last time with the transfer of bytes, and that's a bit weird because I have found two examples which I've also used for this one, and for some reason I get an error when I transfer. So whether that is specific for 3-wire or for SPI, I do not know. I have to find out. So in this video I hope to find out more and also get some more information on whichever it is. I have also fully connected this one, by the way, because I might have an issue with addressing stuff. They're both SPI devices, so I may need to change something, but I'll have to find out. Let's see for software, oscilloscope, and live video stream if applicable. Well, the different view. So this is the code for the camera, which you can see here. And I've shown you the camera is now in a different stand. So maybe you can I can show you a blinking LED or something, but not right now. This is of course the other camera with the probes, DAC and ADC, analog to digital, digital to analog, and program oscilloscope set to SPI with clock data and chip select or whatever name is given to it. It's always inverted. 1 is 0, 0 is 1. Then the big problem here, transfer. I have read the document once again. Lijst, which is a list, literally translated, and you get here some values. This should work, but doesn't. Let's see. No, it doesn't work. Invalid argument. Then, according to the information, if I say this, it should work. Does it? No, it doesn't. So, then SPI open. This says clearly bus device. I have only one bus, but I have two devices in fact, because this is one device and this is the other. So I might just as well say device 2. Would it matter? I don't know. No. For some reason this doesn't work out. This is probably due to the SPI, due to the Raspberry. So it is device 1, but is it bus 1 or like this? I don't know. Let's check. Nope. It even says no such file directory, which is in itself a bit weird. So I need to stay with this. Then I get again 3 wires true. If I change this sequence, 3 wire will be false. It won't work. And the point is, of course, how do you send something using 3 wire? Well, these are modes, and SPI mode is something. SPI mode has 2-bit pattern of clock, polarity and phase. And I do not really know what to make of this. So they do settings. Well, as I found that I have to say, okay, SPI.3 wire is true. It's a binary. No, it's a boolean. So I don't mind this. But what is this exactly? They even have a CS high. Well, CS high means CS bar. Actually, no, CS high means it's always high, and that is not true. So what is this mode anyway? Because minimum is 0, alright, this is 3, but which mode is which? 2-bit pattern. So then I think 0 is completely off, and I may think that 0, 1 is this on and this off. So polarity off, phase 1, and 2, which is then 1 and 0, means polarity on and phase off, because that is binary thinking. and then 3 is both on. I could try that one, SPI mode. I have no idea if it even works or whatever. Just like this one, I have 2 devices, but it doesn't accept 2, and it never did. Bit strange. So let me try SPI mode 0B01. Nope, not here. So where should I put it? Let me put it right here. SPI.mode is just like that. Okay. 0B01, whatever. Does it make sense? Not really. Well, it does something, but if it would matter, well, I don't know. Alright, what if I do this again, and let's see whatever happens with the signals. So let's focus now on the oscilloscope. Does it do something? No. Also, this is always set true. If I take the chance to copy this and put this here, will I get the same result? I don't know. I don't think so, by the way, but I find it very odd that I have to put 3 wires through every time again. Now, see, 3 wire remains true. So that's one thing. Okay. This one can go. And let's shorten this to 500. Okay. The things remain odd. Very odd. This is odd, but let it be. So things still are very weird. I have to be able to send a list, to send some argument. And if you look right here, bus open to send, which you can give any example you want, square brackets, and then to send. And transfer version 1. Nope. Well, it doesn't matter what name you give here. I would think. Although they the point is that here they just say SPI transfer. So if I take this out, just SPI transfer and then the list, what makes that for difference? They keep bothering with invalid argument, and that remains strange. Not unknown, but invalid. So let's keep it to 255 hexadecimal. Must be a list, not an integer. See, that is the point. Must be a list. Well, this is a list. So, how to define a list then? Alright. Let's take it like this. Invalid argument. And I'm doing nothing else than what they say to do. That is the whole weird thing. They have no other errors but this. So here I give an integer. I could have said 255, that doesn't matter. Right here. This is clearly a list, according to the example. And here, once again, invalid argument. And this name doesn't matter. The name doesn't matter. So whatever goes wrong, I am not quite sure what to do. Another one is write bytes. Write a list of values. This one. I haven't tried it yet. So let me cancel this one and instead say SPI dot write bytes list of values. No errors this time, but nothing here either. Does it do anything on the oscilloscope? I forgot to watch. Yes, most definitely. It writes. So if I do different in here, 0, this is also a list. On and off. This would be a very quick on and off. Probably too fast to watch. On the other hand, let's just check how this will go. This might just be a breakthrough or not. It does send anything. That's the point. So let's go with this then. How much does it do? Is this a list as well? I would think so, that the one is also a list. Go. Yeah, that's also a list. So it sent 500 times after another. The value of 255, which reminds me, 255 is maximum, but what is the maximum value you can send from a Raspberry Pi? High. How high is high? That's another one. If I send 1, no, I'm not quite sure about that one. $255 is actually 256, but because you count from 0. So why does this work? But I don't see anything. And does it have anything to do with SPI mode? Let me cancel out SPI mode and go for this one. Can I see something happen? For now, right now, I don't see anything happen. No. Although its program was gone again. So let's go again. Go. Shielding from the light, I don't see a thing. But it was very quick. So let me go for 1000. This was then 1.5 second or so. Let's go. That's not true, by the way. Let's go for 1000. Do I see something with the LED? No. Another thing is, the LED might be broken, so I have to test it. Let's do that. And using the fischertechnik power controller again, with 2 contacts, and you can see it works. So there's nothing wrong with the LED. The question is, if that's not the point, then why don't I see anything? So let's take a look at the schematics. This is the LED to out. Oh, it could be, of course, that I'm using the wrong out point. But how do I know? This is, let's see, I have to take the outer values. So CS bars 1, this one goes D in, it's 8, I don't care, but it is data in, and there are 2. So the big question is, which is out and which out should I take then? So I may have to add an additional wire to see if it is out B that I have to take. That's a good one. So let's see if a short additional or an additional wire may change it. And yeah, before doing that, which should I take? Right, that is 6 indeed. So right next to it. So from here to, let's say, here, if it holds, alright, then I know that they both work. So let's see if this makes a difference. Well, I see that here the signals are going, but I still don't see the LED go. So that's unfortunate. Um, 256, what is half of it? 125, of course. Right, what is hexadecimal for 125? But if it's a value, if it can be a value, so let's make 125. It's a byte as well, after all. And it doesn't do a thing. So that is not the solution, unfortunately. Another thing is that I don't see this move. So that's another thing. Should this move now? I do think so. Why should this signal chip select change? Another thing is that worries me. This. And that was the same thing that is going on with the original program. So let's go there for a moment. And that is this one. For here. And there is no response whatsoever. Okay, so I'm holding them and I don't see anything that even closely resembles what I expect. Except for the fact that it says, okay, like here, it doesn't see anything. Yeah, it it sees the different addresses, well, that's it. That's absolutely it. So I'm not sure which way to go. And looking at the time is up. So testing the LED with this power controller shows that the LED is alright. Adding an additional wire, the yellow one, doesn't solve a thing. Replacing transfer command by write bytes command makes that at least the program runs, but that's all I can tell for now. And well, a nice view with a different camera stand. That is it for now. So thanks for watching. If you like this video, please subscribe to my channel and give the video a thumbs up. Leave a comment or suggestion, very much appreciated. Also, you can follow me on Instagram and Twitter. Please be so kind to support my blog and make a small donation via PayPal or Wired. Also, you can become a patron and have your name mentioned. All information, including the URL of my website, is under this video. Once again, thanks for watching, and have a nice day. This is going to be continued, obviously.